This is Algebra 1, Lesson 10, Practice. They want us to simplify. For the first problem, we have -3 take away 2. There's several different ways we've talked about doing that, like this, and sticking a plus sign in between them, right? Or changing the subtraction to adding the opposite. Either way, you're going to get -5 over. Now let's take these two at a time. -2 plus 8. You're going to the left 2 and then to the right 8. Signs are different, so you subtract. Take the sign with the largest absolute value. Bring down the -6, and 6 minus 6 is 0. Now we ended up with a 0 under, okay? So we can't say that is equal to anything. We can say it is undefined. So this would be your answer, undefined. But of course you would show your work, right? So the work that we did over here. B, let's start with the numerator. -8 plus 6. The signs are different, so we're going to subtract. Take the sign with the largest absolute value. -2 plus 2 would be equal to 0. So we've got a 0 in the numerator. In the denominator, 8 minus 4 is 4, and 4 minus 4 is 0. So we also have a 0 in the denominator. And if you look back at your lesson, it said if you had 0 divided by 0, it has its own special term. It's called indeterminate. Okay, you cannot determine an answer. How many zeros are in 0? Well, we can't comprehend that, right? All right, C. We're going to multiply these, and we can multiply them in any order we want, right? Because that's okay. I think basically the commutative property, right? It's okay, and we know that that says we can multiply in any order we want. I'm going to multiply in this order. No particular reason. It just seems like an easy way to do it to me. And this outside of here is like an opposite, right? So let's do this here. -4 times -4 would be +16, and that's times a -1, okay? And we could go ahead and do this, and we could bring down this symbol that's an opposite. Answer is -16. So this is like saying, what is the opposite of -16? And you would say your answer would be +16. And you could have done it in a different order and you would have gotten the same answer. Okay, here I'm just going to take it from left to right. This is going to be -12. Multiply these two, that's -120. Multiply these two, and that's +240. And again, you could change the order because of the commutative property. E, use 2 unit multipliers to convert 44 square miles. So I'm going to write 44 miles times miles. Yes, it looks like Mimi. Right? All right, and then I've got times. I'm going to have a unit multiplier, but they told us we're going to use 2 unit multipliers. So let's go ahead and leave space for that. Equals, our answer is going to be in square feet. Okay? So let's talk about the unit multipliers we're going to need. What do we know about feet and miles? What do you know? 1 mile equals 5,280 feet. So your unit multiplier, both of these are equivalent. So if we write them as a fraction like this, that's just a 1. It's equal to 1. We could also write it like this. Okay, now how do I know which one I want? Well, I want miles to cancel, so I need miles right here, right? So let's go to the one that has miles on the bottom. So we're going to put 5,280 feet over 1 mile, and that mile will cancel with that mile. And we need to cancel this mile, right? So I'm going to need to do the same thing again, 5,280 feet over 1 mile, and that mile will cancel with that mile. So my units worked out. Okay, I'll be in feet squared here. And I'm going to need to move that over, way over here probably. So when I multiply this out, remember this is like over 1. If you wanted to make a whole number into a fraction, you just put it over 1. So it's going to be 44 times 5,280 times 5,280. And then that's square feet. And that's all over this 1 times 1 times 1, which is just 1. So if you have a 1 in the denominator, you don't need that fraction listed as fraction. It's a whole number, right? So there's your answer to E. And you could work that out and find the answer. And I think they did. I'm looking at the solutions manual. They worked it out. And it is actually, what is that? 1,226,649,600 square feet in that many square miles. Okay. All right, let's look at F. Use 2 unit multipliers to convert 3,500 square centimeters to square meters. So we'll start with what they give us, which is 3,500 square centimeters, but I'm just going to write it as centimeters times centimeters. We're going to use 2 unit multipliers, so we'll have one there and one there. That's going to equal a certain number of square meters. So my unit multipliers for centimeters and meters, what do we know about centimeters and meters? Well, we know that 1 meter equals 100 centimeters. So you could have 1 meter over 100 centimeters, or you could have 100 centimeters over 1 meter. Either would be fine. Both of those are equal to 1. Now here I need centimeters to cancel out. So I need centimeters on the bottom. So let's find the one with centimeters on the bottom. 1 meter over 100 centimeters. That's going to cancel one of the centimeters away. So let's do it again. Okay, and that'll cancel the other one. That's going to give us in the numerator, we're going to have 3,500 times 1, right? So 3,500 over, and then we're going to have 100 times 100 in the bottom. 100 times 100. Now we could do some canceling right here, right? If couldn't we divide the top and the bottom by 10 and then divide the top and the bottom by 100, right? So that would be 35 hundredths meters squared. You could also write as a decimal, 35 hundredths meters squared. Let's think about that. Is that reasonable? We're taking square centimeters into square meters. Okay, so it's not going to be even a whole square meter. Okay, so that does make sense. We would expect that there would not be very many of them. And the solutions manual does give this answer. But again, sometimes they're going to give it not the final computations. It'll just have the steps. And you can just decide how you want to do it there.